Okay, so this lesson is about just algebraic expressions, which isn't anything new to you guys because you've been dealing with these for a really long time. We're just going to touch on this for today and then build on it all throughout Algebra 2. For the first problems, all you're doing is you're taking a phrase and then you're putting it into a mathematical expression. So for the phrase 7 fewer than a number t. You have your number t, you want 7 fewer than that. So what would it be, Jordan? C. Very good. And then the got it question. 2 times the sum of A and B. Jack.
H.
Good. Okay, what if you pick G? Why would G be wrong? Cody.
Because you're just taking it from just A, or you're just adding it or multiplying it to A instead of A and B.
Right, instead of the whole sum. Very good. So make sure you're careful of making the sum in parentheses. Another vocab word that we have that you guys can add to your note cards at some point, the word evaluate. All evaluate means is that you are going to substitute numbers in and then simplify, of course, using order of operations. OOO, meaning order of operations.
I get it.
You start with $20 and you save $6 each week. What algebraic expression models the total amount you saved? First, let's assign a variable to what we need a variable for. What variable do we need? Jordan?
Like X for like however many weeks.
Good. And it doesn't matter which variable you pick. And who can give me the expression? Start with $20, save $6 every week. Jess?
20 plus the quantity of 6x. Or 20 plus 6x.
Yeah. And since you're multiplying, order of operations would indicate that you have to multiply before you add 20 anyway, so we don't really need parentheses here. The got it question, you have $150, you're spending $2 a day. What are we buying for $2 a day? McDonald's.
Gum.
Dollar menu. Gum.
McDonald's.
McDonald's. Okay. A McChicken and fries.
Yeah.
McChicken and sweet tea, even better.
Or just 2 sweet teas.
There we go. Good idea. So who can write this expression for me? Cameron.
150 minus 2x.
And x represents?
Days.
Exactly. Why would we call these two algebraic expressions instead of algebraic equations? Jess?
They don't have equal signs.
Exactly. Now this is where the actual evaluating comes in. Whenever we put in our numbers and then we get an answer. So as you can see, in example A, we're given that A is -4 and B is 5. So just plug those into your equation. That -4 plus 4, we know that equals 0 because of what property from yesterday's lesson? What property talks about adding the opposite and getting 0? Christy? Very good. So we have 0 plus 15 minus 8, and we can evaluate this to get 7. Everyone do B on your own. And I'm just kind of going to come around and see what you get. Now, if you're squaring a number, you are taking that number multiplied by?
0.
Exactly. So 1/2 squared is just like saying 1/2 times 1/2. Remember, multiplying fractions, you multiply the numerators, multiply the denominators. So this is 1/2 plus 1/4. And hopefully some of you realized, hey, I know what that is right away. It's 3/4. Because I've got a hold of fractions. I understand these fractions. And if not, then just make your denominators the same. Multiply the 1/2 by 2/2. 2/4 plus 1/4. Add the numerators, 3. Keep the denominator of 4. And there's 3/4. I'm okay with you guys not showing this step of multiplying by 2/2. If you don't need to make the denominators the same first, if you know in your head 1/2 plus 1/4 is 3/4, that's okay. Just do that right away. All right, then for problem number 4, we're talking about football. A touchdown, 6 points. An extra point kick is 1 point, and a field goal is 3 points. Write an algebraic expression. Now, I'm sure if you guys watch football or if you guys are playing football and you're adding up points, you are certainly not sitting down writing yourself an algebraic expression. But that's what you're doing in your head. Even though you're not saying, okay, T equals touchdown and E equals extra points, you're still doing math in your head. So we are going to use T for touchdown, E for extra point, and F for field goal. So 6 points for every touchdown, 1 point for every extra point, and 3 points for every field goal. And the problem tells us that now that we've written the expression, we need to evaluate the expression. And our team scored 3 touchdowns, 2 extra points, and 4 field goals. So how many points did our team score? Josh?
32.
Very good. And then lastly, we have some additional vocab words: term, coefficient, constant, and like terms. And just so you guys are aware, there is a rules chart on page 21 of the book about simplifying expressions. I didn't put it on here because you guys know those rules. If you need to refer to back to it at all, please refer to page 21. Put a bookmark in it if you would like. But it's pretty much the basics that we went over yesterday, like distributive property, additive inverse, things like that. So as far as these new vocab words go, the word term. A term is just a number or a variable or the product of both of those. So a term could be a number, like 10, or it could be a variable, like y, or it could be the product of both of them, 10y. A coefficient, the number in front of the variable. A constant term is just a regular old number without a variable. Like any number you'd want to pick, negative 47 or 86. Those are constants. And you guys know that like terms are terms that share the same variable taken to the same power. So x squared and x squared are like terms. Are x squared and x to the third like terms? X squared and x to the third. Are those like terms? Make up your mind. Christy?
No.
No, because they don't have the same what? Selena?
Exponent.
Right, they don't have the same exponent. Here's a picture example for you, pointing out your coefficients, the number in front of the variable, -4 and 7, and then it shows that your constant term there is just the number, -6. And then on the right, your like terms, x squared is a like to x squared. And then you can see that the y cubed z is a like term with the -4 y cubed z. Can somebody tell me how many terms are in this expression? Julius?
2.
Remember, it can be just a number.
Oh.
A term can be just a number.
3.
Yes, 3. 1, 2, 3. A term is a number or a variable or the product of numbers and variables. How many terms do we have in this expression? Ashley?
5.
Exactly. And the last thing that we need to do for today is just to simplify these expressions by combining like terms. So for part A, I'm going to have 11x squared Chen?
This is a b minus.
Yes! Thank you, thank you. This is not 11x squared. Do not make that mistake. Because what you need to be paying attention to is whenever you're dealing with both of your x squareds, the 4 has a negative sign in front of it. It is a -4. So 7x squared minus 4x squared is 3x squared. 3y squared plus 2y squared plus 5y squared. What very important step do I need to take in problem B? Morgan?
Distribute.
Yes, very good. Remember, a negative sign outside of a parenthesis is just like a -1. So -1 distributes to 3k, giving us -3k. -1 distributes to m, -m. Distribute the 2 as well, plus 2k minus 8m. And who would like to tell me your simplified answer? Cameron.
-k minus 9m.
Exactly.